All right, in this video, we're going to go over solving equations and solving triangles using the trigonometric functions that we learned about in the last video. So remember, the three trig functions that we have: sine of an angle is the opposite side over the hypotenuse, cosine of an angle is the adjacent side over the hypotenuse, and the tangent ratio of an angle is the opposite side over the adjacent side. So if we are looking at a triangle like this and we're asked to find the length of side x, what we're going to want to do first is figure out what sides we have in relation to this angle that we were given and which trig function is going to be appropriate to use based on the information that's involved. So in this case, we have this angle 35 degrees. We want to see which sides we have to work with, right? If we have the opposite in the hypotenuse, then we're going to use the sine function, and so on, right? So if we look at the 35-degree angle, what we have is side x is the opposite side relative to this 35-degree angle. We also have the side labeled 8 here, and that would be the adjacent side to this 35-degree angle. So we have the opposite side and the adjacent side. We're going to go up here and look at our trig functions, and hopefully this is something that you can see right now, is that we're going to use the tangent function because it involves the opposite and the adjacent side. We wouldn't be able to use the sine or cosine function here because we don't have the hypotenuse involved in this problem, right? We could, if we solve this as it is, we could then go ahead and use the sine and cosine ratios later, but the most appropriate thing to do is use the trig function that involves the sides that you are given, right? So even if we have an unknown here, we know we're trying to solve for this unknown, so that's part of the problem. We want to involve that in our problem solving. And same thing with the side that we were actually given here. This is the opposite side and the adjacent side, so we'll use the tangent function. So all we're going to do is plug in the information that we have from this diagram that we've been given into the tangent ratio, since that's what we decided was appropriate to use here. So tangent, and we have this symbol here, theta, which again just means an unknown angle. In this case, we know the angle measure is 35 degrees. So the angle always goes in this theta spot. So we have 35 degrees. And then our opposite side is x, so we'll leave that as an unknown. And then our adjacent side was 8. So we're just plugging in to the tangent equation here. We put our angle in the theta spot. We put x as our opposite, and 8 is our adjacent because that's what agrees with the diagram that we have. So now the last step here is to solve this, right? We have tangent of 35 equals x over 8. The goal was to solve for side x. So we want to get x by itself, and we'll do that by getting rid of this 8 here. To get rid of the 8, we're going to do its inverse, which would be multiplication here. And again, whatever you do to one side of the equation, you have to do to the other. So we'll have 8 times tangent 35 equals x. Because our 8 and our 8 will cancel here. So all we have to do is multiply then. So we can come over to our calculator and do 8 times tangent of 35. You likely have a different calculator at home. You'd be looking for a tangent button. There should be a sine, cosine, and tangent button all in a row on your calculator. So you can do 8 times the tangent of 35. Make sure your calculator is in degree mode because the angle that we have here is in degrees. All right, check your calculator. If it's in radian mode, your answer is going to be way off. So make sure that you're using degree mode on your calculator. So if we go ahead and enter this gives us a side length of 5.6. So we could label x as 5.6, and we can write here 5.6 equals x. There are no units for this question. We're really just kind of working on the basic concepts here, but obviously if you were given units of inches or feet or whatever it might be for these lengths, then you would apply that unit to the length that you solve for here. All right, so our final answer here would be 5.6 units. So if we look at another example here, similar triangle, not a similar triangle in the math sense, but similar triangle in that it's got some of the same parts and it's a right triangle. So what we have here is an angle measure and 2 sides. So hopefully you're getting the hang of this right now. If you want to pause the video and try this out on your own, that'd be great. So what we have here is an angle measure, and we got to figure out what sides are involved in the triangle diagram that we're given, right? So we have 40 degrees and the sides that we have are the opposite side, and we have the hypotenuse, because across from the right angle, you'll always find the hypotenuse. So we have the opposite side and the hypotenuse. The appropriate trig function to use here would be sine. So we're going to take the information that we have and plug it into the sine function. Sine of our angle, which in this case is 40 degrees, equals opposite, which is 10 in this case, over hypotenuse, which is x. All right, so we've plugged in all our information. Now we want to solve the equation. We're going to try and solve for side x. So this is a little trickier than the last one. There are a couple different ways to solve this. My preference is to divide sine 40 by 1, which is fair game because we can divide anything by 1 and not change its value. And now we've established a proportion. So when we have a proportion, we can solve by cross multiplying. So we can cross multiply here and we'd get 10, and we can cross multiply here and we'd get x times sine of 40. All right, and now to solve this, we want to get x by itself, right? So we're going to do that by getting rid of sine 40. We'll do that by doing its inverse. Sine 40 is being multiplied right now, so the inverse would be division. And we'll want to do, again, the same thing to both sides of the equation. All right, so we can cancel out sine 40 with sine 40 here because we did the multiplicative inverse of division, and we'll end up with 10 divided by sine 40 equals x, and now we can just plug this into our calculator over here, right? If we do 10 divided by sine 40, that'll give us a side length of 15.6 if we round to the nearest tenth. All right, so side x here would be 15.6. And again, we don't have units here, but if we did, you would label them as you're given. In this case, we can just say it would be 15.6 units. All right, so again, the biggest step for these types of problems is to figure out which trig function to use, and in order to do that, you have to figure out what sides you have of the triangle in terms of opposite, adjacent, and hypotenuse. So in this case, we had the opposite and the hypotenuse, so we used sine because that's the trig function that uses those two sides. All right, so we'll take a look at one more example here. Another triangle, right triangle that we have, an angle and two sides. So if you want to pause the video and try this one out on your own, hopefully you're getting the hang of this by now. What we're going to look at here is the sides that we have in relation to the angle. So we have the 55-degree angle here, and what sides do we have in relation to that 55-degree angle? So we look here, we have the adjacent side, because it's next to the angle, and we also have the hypotenuse because it's across from the right angle. All right, so adjacent and hypotenuse, that tells us we're going to use cosine. All right, so to solve this, again, we'll plug in our angle measure was 55, and the adjacent side x, and the hypotenuse 7. So if we want to solve this, we can get x by itself by getting rid of this 7 over here. We'll do its inverse, which would be multiplication. Again, same thing to both sides. So 7 times cosine of 55 would give us x. Again, 7 will cancel out with 7 here because we did the inverse. So 7 times cosine 55 would give us 4.0 if we round to the nearest tenth. All right, so in this case, 4.0 would be our x value for this adjacent side over here. Again, units, add them if you have them. In this case, we'll just call it 4.0 units. All right, so these three problems so far, we've done one example of each of the trig ratios, but so far we've only been solving for sides, all right? But the process is going to be similar with solving for angles. Again, we just want to look and see what sides we have and therefore which trigonometric function is appropriate to use. All right, so this example is slightly different because we're looking for, in this case, an unknown angle, right? Before we had the angle and we're looking for an unknown side. In this case, we have two sides and we're looking for an unknown angle. So in order to do this, we're still going to use the trig functions just as we did before. and the application is just going to be slightly different when we do the algebra to solve. So in this case, we want to do the same thing, figure out which trig function is appropriate to use. So for angle x, we have the opposite side, and we have the hypotenuse, which is across from the right angle. So if we have opposite and hypotenuse, then the appropriate trig function would be sine. So we have sine of x, because x is our unknown angle here, equals the opposite side, which would be 5, over the hypotenuse, which would be 7. So to solve this equation, what we have to use is a function called sine inverse. So you'll see this on your calculator. You should have right above the sine button, you should have a sine inverse button, or if you're using a graphing calculator, maybe in a slightly different spot, but really the sine inverse function should be somewhere close to the sine function no matter what calculator you're using. So sine inverse is the inverse of sine. So it works in the same way as inverses of multiplication, right? If we're trying to do the inverse of 5, right, we would multiply by 1/5 or divide by 5, and these would cancel out to be 1, right? 5 times 1/5 would give us 1, or 1/5 times 5, however you want to look at it. So sine inverse and sine are also inverses, and they're going to cancel out as well. So what we're going to do here is, to solve this equation, we want to get x by itself, right? Our goal would be to isolate this variable x here, and we're going to do that by using the sine inverse function, because to do this we have to get rid of sine, and that's what sine inverse can do, because in order to get rid of something we really have to do its inverse. So what we're going to do here is take sine inverse of sine of x, and whatever we do to one side we have to do to the other. So we're going to do sine inverse to this other side here as well. All right, so what we've done is taken this equation that we have up here, and all we've done is apply the sine inverse function to both sides of the equation. We do that because we want to get x by itself. We want to get rid of this sine here. In order to do that, you have to do its inverse, which is sine inverse function. So we take sine inverse of sine, and those cancel out. So we're left on this side with just x. So we get x equals sine inverse of 5/7. All right? So you can plug this into your calculator now and solve. So if you do sine inverse, or in my case it's labeled as a sine of 5 divided by 7, that gives you 45.6 degrees in this case. All right, so we can label our angle x as 45.6 degrees. All right, so this is a little bit different than when we were solving for a side, but the process is very similar. All right, so we're looking to see which sides do we have in relation to the angles, which trig function are we therefore going to use, and then the only tricky step here is, in order to isolate this unknown angle, we have to use the sine inverse function, or we have other inverse functions. There's an equivalent cosine inverse function and a tan inverse function as well. All right, so we're going to use whatever inverse function of the appropriate trig function that we're using. That'll give us the angle isolated by getting rid of the sine value, and then we take the inverse of the ratio that we established there. All right, so our final answer here, 45.6 degrees. All right, so we'll look at one last example here. We have a similar problem, right, where we have an unknown angle x here, and we have two sides. So first thing, identify which trig function to use. We have the opposite side from angle x is 13, and we have the adjacent side to angle x is 6. So in this case, we have the opposite and the adjacent. That tells us we're going to use the tangent function. All right, so tangent is opposite over adjacent. We can go ahead and solve here. Tangent of angle x, our unknown angle x here, is opposite 13 over the adjacent side 6. All right, so again, the same thing we're going to do to solve here is use the inverse function that's appropriate. In this case would be tangent inverse. All right, so we're going to apply tangent inverse to the tangent of x side. equals, and again, whatever you do to one side of the equation, you have to do to the other. So we're going to do tangent inverse of 13 over 6 as well. And again, to solve here, we have tangent inverse and tangent will cancel out with each other because they are inverses. And x equals tan inverse of 13 over 6. All right, so to solve this, we can go over to our calculator. Again, you'll find your tangent inverse button right near your tangent button on your calculator. Mine is abbreviated as atan, but it's the same function that we're using. So tangent inverse of 13 over 6 would give us 65.2 for our angle. So angle x here would be 65.2 degrees. And we could label it in here as 65.2 degrees as well. All right, so when you're solving these triangles using trig functions, just a quick review, the biggest thing is to first figure out what sides that you have and then which trig function you should use because of the sides that you have. All right, with this question here, we couldn't have used sine or cosine because the hypotenuse isn't involved, and both sine and cosine involve the hypotenuse. All right, so it's just a little bit of a puzzle figuring out what pieces you have to work with and which trig function is going to fit with those pieces that you have. So figure out what trig function is appropriate, plug the numbers in that you have into the appropriate spots in the trig function, and then solve. If you're solving for a side, you're going to use algebra to do that. If you're solving for an angle, you'll have to use one of these inverse functions, either sine inverse, cosine inverse, or tangent inverse. All right, thanks for watching this video, and I'll see you in the next one.